Hello friends, today we are going to solve some problems for design for fluctuating load, finite life problems, reverse load. Let us start with one example. A rotating bar made of steel 45C8 SUT is equal to 630 Newton per mm square is subjected to a completely reverse bending stress. The corrected endurance limit of the bar is 315 Newton per mm square. Calculate the fatigue strength of the bar for a life of 90,000 cycles. Okay. Let us solve this example. First of all, given data in which ultimate stress of material is given, this is 630 Newton per mm square. And corrected endurance limit, that means SE is 315 Newton per mm square. And number of cycles is 90,000. Now the step 1, first of all we have to construct the ascent diagram. Okay. So for that, to construct the ascent diagram, we have to find the different values, in which first is 0.9 SUT. So value of SUT is given 630. So 0.9 into 630 is equal to 567 Newton per mm square. Now find the log 10 base 0.9 SUT. So log 567, this value is 2.7536. Now find out the log SE. So log SE, and the value of SE is 315. So value is 2.4983. Now log N, and N is equal to 90,000. So the value is 4.9542. Log 10 raised to 3. So log 10 raised to 3 is equal to 3, and log 10 raised to 6 is equal to 6. Okay. Now let us construct the ascent diagram. How to construct the ascent diagram? You can see this is the ascent diagram, on which you can take on x-axis it is log n, and on the y-axis it is log sm. Okay. Now here at this point it is log 0.9 SUT, and the value is 2.7536. Here at this point it is log SE, and the value is 2.4983. Here it is on this axis, it is 3, 4, 5 and 6. Now value of N is 90,000. So we have to find the corresponding value of this SF dash. Okay. So it is, we have to find the corresponding value of this N. So step 2, this is to find out the fatigue strength for the 90,000 cycle. Okay. So it is given by the equation. Here you can see this log SF dash is equal to, you can say 2.7536 minus here log 0.9 SUT minus log SE upon 6 minus 3. Okay, into, so the total value is 2.5873. Okay, 2.5873. Now find out the corresponding value of SF. So SF is anti-log of this 2.5873. So value of stress is 386.63 Newton per mm square. So the fatigue strength corresponding to 90,000 cycle is 386.63 Newton per mm square. Okay. Now let us another example. A fourth steel bar 50 mm in diameter is subjected to a reverse bending stress of 250 Newton per mm square. The bar is made of steel 40C8, SUT is equal to 600 Newton per mm square. Calculate the life of the bar for a reliability of 90% and value of Ka surface finish factor is 0.44. First of all, given data in which SF or we can say bending stress sigma B is 250 Newton per mm square is given. Ultimate stress 600 Newton per mm square. Reliability 90%, so the corresponding reliability factor Kc is equal to 0.897. Now construction of SN diagram. So as per the previous example, let us find the value of 0.9 SUT, then log SE dash. So SE dash is given by the standard value 0.5 SUT. Okay, so SE dash, that is the endurance limit of standard specimen, is 300 Newton per mm square. Now for 50 mm diameter, so size factor Kb for 50 mm diameter from the standard value it is 0.85 and Kc is 0.897. Now here stress concentration factor is not given, so take stress concentration factor Kd is equal to 1. So our equation for the endurance limit Se is equal to Ka into Kb into Kc into Se dash. Now put the value. Ka is equal to 0.44, Kb is equal to 0.85, Kc is equal to 0.897 and Se dash is equal to 300. So value of Se endurance limit is 100.64 Newton per mm square. Now construct the SN diagram. SN curve. For that required values, first of all 0.9 SUT, 0.9 into 600, so 540 Newton per mm square. Log 0.9 SUT is equal to 2.7324. Log SE is equal to 2.0028. Log SF is equal to 2.3979. Also log 10 raised to 3 is equal to 3 and log 10 raised to 6 is equal to 6. Now construct the SN diagram. You can see at point A it is 0.9 log 0.9 SUT and value is given. At point B it is log SE. Okay. Now value of SF is given here 2.3979. We have to find the corresponding life of this trace log n at here. Okay. Now you can see here two similar triangles are there, AEF and ADB. These are the two similar triangles. Now in the similar triangles we can say EF. EF means EF. We have to find the log n. So EF is equal to DB into AE upon AD from similar two triangles. Now DB means 6 minus 3. AE means 2.7324 minus 2.3979 and AD 2.7324 minus 2.0028. So value of EF is equal to 1.3754. Okay. Now you can see here in this axis the initial point is 3. So value of n, to find out the value of n, you can say log n is equal to 3 plus EF because it starts from 3. Initial point is 3. So that's why it is 3 plus EF. So 3 plus 1.3754. So now antilog. So log n is equal to 4.3754. Now take the antilog of this. So number of cycle n is equal to 23,736.2 cycle. This is our answer. Okay, thank you very much. Stay safe.